Welcome to Electrified. Yes, Tesla is innovative, everybody knows that, but there is one aspect of the Cybertruck in particular that is revolutionary, that is changing the landscape of not just automotive, but space travel forever. Yet no one seems to really care. The synergies and cost reductions that will result from this unofficial partnership between SpaceX and Tesla are truly incredible and literally cannot be duplicated by any other automaker. And no, the topic for today is not the 8,000-ton gigapress Tesla will use for the rear body of the Cybertruck, the newest, biggest gigapress in the world, an entire 2,000 tons heavier than the gigapress being used for the Model Y, which they need because the longer truck bed that will need to support a lot of load requires an even bigger casting machine. This deserves attention for sure, just not today. We did get a bit of light shed on this subject at Battery Day when Elon mentioned material science, but to be expected, this went mostly overlooked. And his mention of it was with regard to battery manufacturing, but today we are talking about one aspect of the Cybertruck and indirectly of SpaceX's Starship that shouts to the world how revolutionary Tesla really is. And this is not just something they've done here and there over the years, it's the very air the company breathes. First principles thinking and constantly and continuously creating and implementing new improvements. So back in December 2015, Tesla actually put the world on notice when they hired Charles Kuehmann, the alloy expert who left Apple to join not only Tesla but SpaceX as well to lead the materials engineering divisions at both companies. Prior to Apple, he earned a PhD in material science and engineering from Northwestern, and then he co-founded a company, Quest Tech, 2 years later to commercialize the work, where he then spent 18 years directly in the material science field. Quest Tech went on to successfully develop and commercialize not only several new materials engineering tools and processes, but also numerous new alloys. He was later the head of product design at Apple for 3 years before then leaving to join Tesla and SpaceX, where he still works today. Just a few months back, we heard the rumor that Steel Dynamics Inc. or SDI signed a supply agreement deal with Tesla for the Cybertruck. SDI has a new electric arc furnace or EAF steel mill under construction in Sinton, Texas that is supposedly going to supply steel to Tesla for the Cybertruck. EAF is just the method responsible for making about 25% of the world's steel, which uses high current electric arcs to melt steel scraps and convert them into liquid steel of a specified composition and temperature. Scrap steel is widely available at lower cost, but we'll come back to this later. Then just a few days ago, Metal Center News reported that Ferris 85 will install and operate the largest slitting line in North America at SDI's new Sinton, Texas factory, providing SDI with slitting of hot rolled material. But Dylan, Tesla is going to use cold rolled steel. Yes, you're right, but we'll get there shortly. Slitting is a metal manufacturing process where a material like aluminum or steel is slit into lengths and widths specified for the end application as the material is moved through the sharp circular blades making the cuts. This Ferris 85 slitter, which should be operational by September of this year, is capable of making slit widths ranging from 6 inches to 85 inches or about 7.08 feet. And yes, Tesla is creating its own alloy at Tesla, and Elon told us it's not a problem to create a lot of it, but Tesla will need to come up with new body manufacturing methods as a result of using this new alloy. This brings us to the material science breakthrough where Tesla has yet another competitive edge with this proprietary stainless steel alloy. So just like Tesla creates their Hardware 3 and Hardware 4 full self-driving chips in-house, but does not actually manufacture them, we can seemingly expect a similar situation with a new stainless steel alloy for the Cybertruck. The SDI factory in Sinton, Texas is about 3 hours away from Giga Texas in Austin. So the real secret to Tesla's dominance hiding in plain sight starts with the ultra-hard 30X cold-rolled stainless steel proprietary alloy that Elon said could break a stamping press, which is why the Cybertruck design was so planar. You can't stamp this new stainless steel alloy. And yes, it was never 30 times. It's 30X. But I will explain this shortly. But before we get into it, this response from Elon to Viv says Elon and co decided to use this new steel on Starship first and then later decided to make the change and implement it into the new Cybertruck, adding that Tesla was going to use titanium skins for Cybertruck originally, but the stainless option was much stronger. So this hints at something much bigger, that what Elon is really doing is creating more demand for whatever alloys SpaceX settles on to drive up the volume of production and ultimately drive down the material costs. As we know, higher volumes lead to lower costs, a win-win for SpaceX and Tesla. It's brilliant. Now yes, I will add a caveat that the demand for space alloys is a bit different than Earth alloys, as the Cybertruck will not have re-entry into the Earth's atmosphere issues like extreme heat, as on Earth we're mostly just looking for rust inhibition. But as SpaceX continues to change materials, I would not be surprised to see Tesla do the same with the Cybertruck. As you can see, last summer Elon said they were rapidly changing alloy constituents and forming methods, so traditional names like 304L will become more of an approximation. This is a very key tweet that tells us the traditional naming methods under the stainless steel umbrella will not be as relevant, at least for Tesla, and two, that this is a continuously evolving endeavor. Most traditional automakers pick a material, pick a design, and then run with it for 100 years. Tesla is the antithesis to this strategy, as one of their main edges is constant research and development at the most fundamental chemistry level to constantly improve and, more importantly, implement these advances. And to translate to a practical benefit for the average non-Tesla nerd, a truck that is incredibly resistant to scratches and stuff like this, one that won't dent, and one that also doesn't rust, which by the way is a bigger problem than most think. So what is 304L, 30X, cold rolling, alloys, etc.? I could honestly sit here and talk about it for hours, but I'll just give you the key talking points and important takeaways. First off, when Elon says ultra hard, some sheet metal engineers would have a bone to pick with him, as the correct engineering term would be strong, as in strength or yield strength. And yes, Elon knows this, but he also knows the average Tesla fan has no clue what yield strength means. But now you will. The yield strength or yield stress is just the point where a material begins to deform plastically, and plastic behavior is just a material undergoing a permanent change in shape due to force put on the material. So yield strength determines the maximum load or the upper limit of force that can be applied without producing a permanent deformity or change in shape. Next up, 30X. What does this mean? Thanks to Thomas Broadfoot, we got an answer back at the end of 2019. He asked Elon if the 30X was with regard to the alloy type and the X was an unknown variable like 303 or 304, or if it really meant 30 times hardness. Elon replied, "Good question. It's a new variant of 300 series stainless steel, but it also gets cold worked many times depending on kilotonnage of press." So at that time, it was not exactly 303 or 304, but a new series, and it does get cold pressed more than once, but how many times will vary based on the press. The 300 stainless steel series is a category of alloys that belongs to the austenitic family, making them corrosion resistant, durable, and affordable. Elon described the alloy they plan to use as 3 millimeters thick or 0.118 inches, so just over a tenth of an inch thick. For comparison, most other door panels are 0.7 to 1 millimeter, so the Cybertruck steel is 3 times thicker than most other doors. And steel comes in the form of a crystal structure, either face-centered cubic or body-centered cubic. When you heat it up and then cool it off, it shifts from one phase of the crystalline structure to the other. This is what is being referred to if you hear austenitic versus martensitic. Austenitic stainless steel is not magnetic, but cold working or cold rolling can make them slightly magnetic at times. And there are many stainless steel types under the 300 series umbrella. And real quick, the L that Elon mentioned in the earlier tweet can be interpreted as meaning extra low carbon, as 304 stainless has a maximum carbon content set at 0.08%, whereas 304L has a maximum carbon content of 0.03%. 304L is actually a bit structurally weaker than 304, but the benefit is 304L's lower carbon content that helps during the welding process, even in corrosive environments, meaning the weld joints should hold up better over time. So just like with battery chemistries having pros and cons or trade-offs, it's the exact same situation with the various stainless steel series types. And the last indication from Elon about the specific series of stainless steel was 304L, but remember, this is going to be a proprietary alloy, meaning a 3.0 Tesla is really a better name, as none of the traditional 300 series alloys is what Tesla and SpaceX will actually use. But we do know that it's going to be cold rolled, which is a type of work hardening and a finishing process that compresses hot rolled steel in between a series of power rollers in order to make harder and thinner steel sheets. Cold rolled stainless steel is great for applications where high precision, high strength, and better surface characteristics are required. Basically, as the pressure is applied to the hot rolled steel in the cold rolling process, the crystalline structure is elongated and dislocated along the direction of the roll, which increases the yield strength of the material. So if you remember from earlier about Ferris 85 supplying Tesla with hot rolled steel, the cold rolling is the step after the hot rolling that ultimately produces a steel with high tension breaking resistance and an increased resistance to deformation or changing of shape. And a common misconception with cold rolling is that there is a layering taking place. There is not. Cold rolling is done mainly to keep tight tolerances in thickness and flatness for uniformity, and of course, as mentioned, better tensile strength. But an overlooked benefit is the refined, smooth surface finishes as it comes off the rollers. And one last reminder, do not say 30 times rolled or 30 times harder. Yes, it's possible to roll 30 times in theory, but it makes little manufacturing sense as tolerances do not improve infinitely with more rolls, and with each roll you increase the internal stress. Plus, it's not even what Elon was referring to in the first place. As Elon said though, you cannot stamp this ultra hard 30X steel, and even bending it requires a deep score on the inside of the bend, which is how the Cybertruck prototype was made. Essentially, a material that is cold worked to the point of its tensile strength, it then has no ability to stretch or form. If the material is cold rolled or worked to its maximum, any additional cold work, like forming in a press, pushes the material past its tensile limit, causing it to fail or crack. So that new manufacturing process Elon mentioned that Tesla would have to create with his new stainless steel alloy requires minimal forming operations of the stainless steel, enabling huge cost savings. So the body panels for the Cybertruck will be laser cut, and the standard stamping was not implemented in the Cybertruck prototype. With the flat panels and straight lines or the planar design, Tesla does not need stamping dies in order to shape the body panels, as they can just laser cut the panels to size. And I didn't even mention the exoskeleton design or cell to pack structure or any of the other incredibly important and truly revolutionary methods Tesla is going to implement with the Cybertruck. Elon showed us at the Cybertruck reveal videos of the skin being bulletproof to a 9mm full metal jacket from 10 meters and sledgehammers from point blank range. And yes, I know some of you will start typing about accidents and repairs for this new stainless steel behemoth of a vehicle. The truth is, no one knows how this is going to play out. We can assume fender benders won't cause much damage to the Cybertruck, but more serious accidents are probably going to cause some real challenges to repair or fix, and it's a valid point to consider. Not only will Tesla, but eventually all body shops will need to learn new repair methods for this proprietary stainless steel built exoskeleton on a structural battery pack. But that's all I have for you guys today. Please take a moment to like the video if you did, consider subscribing for more Tesla content, and I hope to see you in the next video. I hope that you have a great day.